February 25, 1991, the Persian Gulf. The night air is thick with the scent of salt and the heavy metallic tang of burning fuel. Above the dark expanse of the water, the silence is not a void but a fragile tension. Deep within the steel bowels of the USS Missouri, 5 decades of history breathe in the rhythmic hum of machinery. The mighty Mo, the Titan, that once saw the surrender of empires now finds herself stalking the coast of the far peninsula, a relic of a different era thrust into the electronic age of Desert Storm. On the shoreline, hidden within the jagged shadows of the dunes, a different kind of predator waits. An Iraqi battery eyes fixed on the green glow of their scopes identifies the massive radar signature of the battleship. They do not see a legend, they see a target. With a roar that shakes the desert sand, 2 HY-2 Silkworm missiles tear into the sky. The Silkworm is not a weapon of elegance. It is a primitive subsonic beast, a relic of Cold War engineering, designed to do one thing: kill. It carries a 1,000-pound warhead, a concentration of high explosives capable of snapping a ship's keel like a dry twig. It doesn't fly high where it can be easily spotted. It skims the tops of the waves, a grey shadow masking itself against the clatter of the sea. It is a predator that stays low, waiting for the moment of impact to announce its arrival. On the bridge of the Missouri, the atmosphere shifts in a heartbeat. The electronic silence is shattered by the piercing rhythmic scream of the SLQ-32 sensors. Contact, 2 contacts, inbound, fast, low. In the Combat Information Center, CIC time ceases to be a linear progression. It becomes a series of frantic calculated heartbeats. The fleet has seconds, not minutes, seconds. The Missouri reacts with the instinct of a veteran. She blooms. A massive cloud of chaff, millions of tiny strips of aluminum foil, is launched into the sky. To the primitive seeker head of the first Silkworm, this expanding cloud of metal looks more like a ship than the ship itself. It takes the bait veering sharply and plunging harmlessly into the cold waters of the Gulf. A fountain of white spray marks its failure. But the second missile is smarter, or perhaps just luckier. It ignores the glittering cloud. Its radar lock remains fixed on the 50,000 tons of American steel. It is closing. In this moment, the nature of naval warfare shifted. Standing guard beside the battleship is the British destroyer HMS Gloucester. Her crew sees the trajectory. They understand the math of the impending catastrophe. There is no time for committee meetings or long chains of command. The Sea Dart system is engaged. 2 missiles streak from the Gloucester's deck, trailing fire across the black sky. In a flash of light that illuminates the horizon, they intercept the Silkworm mid-air. The threat is vaporized just seconds before it would have torn through the Missouri's hull. It is the first time in combat history that an incoming anti-ship missile has been killed by another missile. But war is never as clean as the after-action reports suggest. As the debris of the Silkworm falls, the fog of war descends, a thick psychological haze that blinds even the most advanced sensors. 3 miles away, the frigate USS Jarrett is riding shotgun. On her deck, the Phalanx CIWS close-in weapon system, a white R2D2 shaped dome housing, a 20mm Gatling gun, is already alive. Its radar is sweeping the sector, its safeties are off, it is set to autonomous. This is the dangerous paradox of the machine. The Phalanx is designed to bypass the slowness of human hesitation. It doesn't feel fear, it doesn't flinch, it doesn't double-check its target. It simply runs the math. As the Jarrett's radar sweeps the sky, it doesn't find the Silkworm. That threat has already been neutralized by the British. Instead, it finds the massive cloud of chaff still hanging in the air above the USS Missouri. To the fire control computer, this rapidly expanding metallic cloud isn't a decoy. It looks like a missile in its final terminal dive. The algorithm executes its logic. Threat detected. Engagement authorized. The hydraulics scream as the turret slews. The barrels spin to 4,500 rounds per minute, a terrifying mechanical roar. A stream of 20mm armor-piercing tungsten rounds rips through the air. They do not hit an enemy, they slam into the USS Missouri. 4 rounds penetrate the superstructure, bypassing the heavy belt armor and striking the captain's cabin. This wasn't an act of malice, it wasn't a glitch in the traditional sense. It was a cold, calculated error of logic. The last line of defense became the primary threat, not because it failed, but because it did exactly what it was programmed to do. It was a textbook case of blue on blue. That was 1991. Now look at the USS Gerald R. Ford today. She is a $13 billion marvel of the 21st century, the apex of naval engineering. She possesses nuclear-powered electromagnetic launch systems and sensors that can see across the horizon. And yet bolted to the side of that futuristic flight deck, you see the same gun, the same white dome, the same silhouette. The Navy calls it the last line of defense. I call it a blind madman. Why do we continue to bolt a piece of Cold War hardware, a weapon that once shot its own friends onto the most advanced warships in human history? Why do we keep it when the laws of physics suggest it is statistically useless against the modern hypersonic threats of the new millennium? The answer isn't found in the halls of politics or the brochures of defense contractors. It is found in the raw-cold engineering reality of the world we have built. Welcome to Navy Decoded. Today we don't look at the ribbon-cutting ceremonies or the polished press releases, we look at the arithmetic of attrition. We look at the only weapon that allows us to trade cheap lead for expensive threats. Let's strip away the layers. Let's look at the physics. When you do, you realize this weapon is trying to fight a war it was never designed for. The Phalanx was born in the 1970s. Its original mission was clear: kill the Harpoon and the Exocet. These are subsonic cruise missiles, sea skimmers, moving at roughly Mach 0.9 to Mach 2. For a radar tracking algorithm, Mach 2 is polite. It is predictable. It gives the computer time to think. Time to calculate the lead angle and time to physically move the heavy gun barrels into the path of the target. But the variables of the 1970s are dead. Today the threat isn't Mach 2, it is hypersonic. We are talking about the Chinese DF-17 or the Russian Zircon. These weapons travel at Mach 5 plus over 1 mile every second. This creates a mechanical crisis of angular velocity. The Phalanx turret has a physical limit. Its hydraulics can traverse at about 115 degrees per second. While that sounds fast in a laboratory against a hypersonic vehicle, it is moving in slow motion. Imagine a Zircon missile approaching at Mach 5 at a range of 1 kilometer. If that missile pulls a high G maneuver or a terminal dive, the angle of engagement changes faster than the metal of the gun can physically turn. The mechanics hit a wall. The computer knows exactly where the target is, but the gun cannot catch up. It is always firing behind the target. It is quite literally chasing a ghost. And it gets worse. The modern hypersonic glide vehicle doesn't just fly fast, it maneuvers randomly. The Phalanx fire control computer relies on lead point prediction. It assumes that if a target is here at point A and moving at speed x, it will be at point B in 1 second. But when the target is jinking, shifting its flight path unpredictably at 5 times the speed of sound, those algorithms become useless. You cannot predict the future of a chaotic variable. You can only guess. And in naval warfare, a guess is a death sentence. Beyond the speed and the chaotic dance of the missile, there is the issue of total sensory blindness, what engineers call the plasma sheath effect. When an object travels at Mach 5 or higher, the friction against the atmosphere isn't just heat, it is a violent molecular transformation. The air around the missile is compressed so intensely that it ionizes, turning into a wrapper of superheated plasma. This plasma acts as a physical shield against the Phalanx's radar. It is in essence a stealth cloak made of fire. The plasma swallows the radar waves, the return signal, the echo. The gun needs to see simply dies, the sensor goes blind. And it doesn't just blind the radar, it deceives the optics. Even if the system switches to its infrared camera looking through, that plasma is like trying to aim a rifle through the heat mirage of a sun-baked highway. The target shimmers, it wobbles. The computer finds itself chasing a thermal ghost because it cannot find the solid metal hidden underneath the flame. But let us play devil's advocate. Let us assume a miracle occurs. Let us assume the Phalanx, against all mathematical odds, gets a lock. Let us assume the stream of tungsten rounds hits the hypersonic missile dead center. You still die. This is the kinetic trap. You don't need a degree in physics to understand this. You only need to understand momentum. Think of it this way. If a 2-ton steel safe is dropped from a skyscraper toward your head and you shoot it with a shotgun, you haven't saved yourself. You haven't stopped the safe. You have simply turned one solid heavy object into 1,000 jagged pieces of shrapnel, all still falling on your head at the exact same speed. If the Phalanx shreds a hypersonic missile at a range of 500 meters, the wreckage doesn't just stop and fall. Physics dictates that the debris keeps moving forward at Mach 5. Instead of being hit by one solid missile, your ship is now hit by a supersonic shotgun blast of burning titanium, unspent volatile fuel, and jagged warhead fragments. This debris field hits the hull with the force of a freight train. It shreds the radar arrays, tears through the unarmored superstructures, and ignites the jet fuel on the flight deck. Against a hypersonic threat, the Phalanx is not a shield. It is a placebo. It offers psychological comfort to the crew, but it does not offer physical survival. Any rational engineer looking at these numbers would rip these guns off the deck and throw them into the Atlantic. But the US Navy isn't doing that. They are keeping them. They are maintaining them. They are bolting them onto the newest ships in the fleet. Why? Because the enemy isn't just sending hypersonics. They are fighting a different war entirely. A war of economics. War is not just about who has the bigger gun or the faster missile. War is about logistics. War is about insolvency. If I can make you spend $1 million to shoot down a $10 kite, I have already won the war before the first shot is fired. This is the grim reality of the Red Sea crisis we see today. The enemy, the Houthi rebels, aren't firing Mach 5 missiles every day. They are firing drones, cheap plastic lawnmower engine suicide drones. These things cost perhaps $20,000, sometimes less. Now place yourself in the combat information center of an Arleigh Burke-class destroyer. The radar screen lights up. A swarm of 10 drones is inbound. You have to kill them. You cannot let them hit the ship. What do you have in your magazine? You could fire the SM-6 missile. It is the Ferrari of interceptors, incredible range, incredible accuracy, but it costs over $4 million per round. You could use the workhorse, the SM-2. That will set the taxpayers back $2.5 million per shot. Even the smaller evolved Sea Sparrow missile ESSM costs $2 million. Do you see the math of the graveyard? Using a $2 million missile to kill a $20,000 drone is not a victory. It is a slow-motion economic defeat. It is an exchange ratio of 100 to 1. If the enemy launches 100 drones, they spend $2 million. To stop them using your primary missiles, you spend $200 million. This is the formula for bankruptcy. We will run out of money and missiles long before they run out of plastic and lawnmower engines. And it gets worse. A destroyer has a limited number of vertical launch system VLS cells. These are the ammunition pouches of the ship. Once they are empty, the ship is a floating target. If you waste your precious SM-6s on trash drones, what happens when the real anti-ship ballistic missiles show up an hour later? You are empty. You are dead. This is where the blind madman finds his redemption. The Phalanx is not on the deck to fight the high-end war of the future. The Phalanx is the janitor. It is there to take out the trash. Despite inflation and the rising cost of strategic materials, a single 20mm tungsten round costs roughly $46. A standard kill burst from the Phalanx takes about 300 rounds. The total bill for a dead drone, $13,800. Now compare those figures, $13,800 versus the $2 million price tag of an interceptor missile. Even with the price of tungsten, that is an efficiency ratio of roughly 1 to 145. This math saves the fleet. The Phalanx clears the sky of the cheap, slow-moving garbage so that the advanced Aegis system doesn't have to waste its Ferraris on garbage trucks. It preserves the ship's most critical asset magazine depth. This is American pragmatism at its most brutal. We don't always solve problems with elegance. We solve them with volume. We solve them by making the cost of the defense lower than the cost of the threat. But the engineers at Raytheon knew that being cheap wasn't enough. They remembered the USS Missouri. They knew they couldn't have a robot that shot at its own shadows or its own friends. The madman needed eyes. This led to the Block 1B upgrade, the version defending the fleet at this very moment. The engineers did something brilliant. They didn't change the gun. The M61 Vulcan is a masterpiece of mechanical violence. You don't touch perfection. Instead, they changed the way the gun sees the world. If you look closely at the side of the white radar dome on a modern ship, you will see a small rectangular lens. That is the forward-looking infrared sensor, or FLIR. This single addition changed everything. Radar is powerful, but it is easily fooled. As we saw with the Missouri, a cloud of aluminum foil chaff is a radar's worst nightmare. It is a wall of static, but FLIR does not care about metal. It sees heat. A decoy cloud is cold, it has no engine, no friction, and it dissipates its energy into the air almost instantly. A drone engine, however, is hot. A missile exhaust is scorching. The Block 1B doesn't just guess anymore. It cross-references. The computer compares the radar return with the thermal signature. If it sees a cold drifting blob, it ignores it. If it sees a hot, fast-moving streak, it kills it. The blind madman didn't just regain his sight, he gained a new hunting ground entirely. For decades, the Phalanx was considered useless against the threat of small, fast attack boats. The culprit was sea clutter. To a traditional radar, crashing waves and salt spray look like a million false targets. A low-profile fiberglass hull hides inside that static like a needle in a haystack. But the FLIR sensor changed the rules of the game. It ignores the waves, it looks for temperature contrast. The ocean is a cold black void. The engine of an Iranian fast attack craft is a screaming hot light bulb against that darkness. The contrast is absolute. The clatter is gone. Now the Block 1B can lower its barrels to the horizon and turn those suicide boats into driftwood before they ever get within striking distance. And this technology didn't just stay on the ships. During the height of the Iraq War, a new threat emerged, mortars and rockets raining down on the green zone in Baghdad. The engineers did something that sounded insane at the time. They took the Phalanx off the ship, mounted it on a heavy HEMTT truck and parked it next to the barracks. They called it the Centurion CRAM counter-rocket artillery and mortar. It worked. The Centurion tracked incoming mortar shells, targets smaller than a Coke bottle, and shot them out of the sky with terrifying precision before they could hit the ground. It saved hundreds of American lives. It proved that this old dog could learn new tricks if the sensors were smart enough. To make this work, they also had to fix the ammunition. The Navy stopped using the old depleted uranium rounds because of environmental concerns and red tape. They switched to tungsten, the Mark 244 Mod 0. Why tungsten? Because it is nearly twice as dense as lead and harder than steel. When a tungsten penetrator hits at 3,600 feet per second, it doesn't need an explosive charge. The kinetic energy alone atomizes the target. It shreds engine blocks, it snaps airframes. This is hit to kill in its purest mechanical form. But the real secret sauce of the Phalanx is a process called closed-loop spotting. Most guns guess where a bullet will go based on wind gravity and barrel wear. The Phalanx radar tracks two things simultaneously. It tracks the target and it tracks its own stream of outgoing bullets. Imagine holding a high-pressure fire hose in the dark. You can't see the target clearly, but you can see where the water is hitting. You adjust your aim based on the splash. The Phalanx does this electronically. It measures the error between the bullet stream and the target in real time. If it sees the bullets drifting a fraction of a degree to the left, it cranks the hydraulics to the right. It performs this correction loop nearly 100 times every second. It walks the fire onto the target like a fire hose of lead. We have covered the physics, we have covered the economics, but does all this engineering actually work when the alarms go off and the steel starts flying? Ask the crew of the USS Gravely. January 30th, 2024. The Red Sea. Night has fallen and the tension is a physical weight in the air. A Houthi anti-ship cruise missile slips through the outer defensive layers. The long-range SM-2s didn't kill it. The mid-range ESSMs didn't kill it. It is screaming toward the ship at high subsonic speed. It gets within 2,000 yards of the hull. At that range, you don't have minutes to pray, you have seconds, 3 seconds to impact. The radar operators in the CIC are staring at death. But the Phalanx Block 1B was waiting. It detected the threat, it verified the thermal signature, it spun up. The tungsten wall slammed into the missile. The warhead detonated in the air just a few hundred yards from the ship. This was the first confirmed kill of a cruise missile by a Phalanx in modern combat history. The ship was saved, the crew went home. But don't get comfortable. That victory exposed a terrifying mathematical truth. The Phalanx has one fatal flaw that even tungsten cannot fix.